Today is September the 26th. By the time I'm done with you, you'll have 4 methods for solving quadratic equations. There will be factoring, the quadratic formula, completing the square, and of course, graphing. So graphing quadratics is a big part of what we do in this class, and we want to be good at understanding how the graph and the equation are related to each other. So anyways, that'll be the 4th method, and we won't probably talk about that one until we've done some work on actually how do you graph a quadratic. So for today, I say this ought to look massively familiar to you. So we're solving quadratic. And by the way, the term quadratic, in case you have forgotten, refers to expressions in math that have x to the second power. So x to the second power is a quadratic. If it goes any higher than that, if you had like x to the second, but then you also had x to the third, no longer is it called a quadratic. It would, of course, be called a cubic. And so we're just going to solve a bunch of equations. I think they're simple equations that all have a degree of 2, meaning that the highest power of x is 2. So start super easy. Hopefully you're not too rusty. Yeah, it does. It's a good smart person question, and I've always asked the same question. 4 has its own name, Kevin. It's quartic, Q-U-A-R. And I've never really given myself a great answer as to why quadratic was selected for 2. So I would have asked the same question if I were you. You could Google it if you'd like. Not right now because I need you listening, but at some point, I'd be interested if one of you can find a good explanatory sort of website or something. I'd be interested to know why the selection of quadratic. But again, 4 is quartic. So anyways, excellent thinking. Quadratic equations have x to the power of 2. There's your first one. And here we go. We're going to dive right in like the old cold swimming pool theory. Just jump in, right? So any of you guys remember how to factor? 9th graders, it ought to be more vividly there since for you, it was only like 5 months ago. So when you factor a quadratic, you're basically just looking for a multiplication problem that equals this. All right, this should come back to you relatively quick. So since we're factoring, then we know to make x squared that we need an x here and an x here. And then we know also that the numbers that we put here and here in the little blue spaces have to multiply to make -14. I sometimes question whether or not I'm any good at this job when people don't hear me say that, so I'm going to say it again. Priority number 1 is to pick 2 numbers that multiply to make -14. You have options. -1, +14, +1, -14, +14, -1, +7, -2, -7. You have options, but your first priority is to make the -14. Our secondary priority is that when we put numbers in, these 2 products, this one times this and this one times this, will add to make 5x. Making the 5x is a secondary objective, equally important, but not our first focus. Our first focus is the -14. So if this is not super rusty in your mind, you already know what the numbers are. What are they? Yes, we need a +7 and we need a -2. And in case, again, you're a little bit rusty with this, allow myself to show yourselves why this works. Good job there, Bryn. If I multiply these 2 together, what is 7 times x? And what is x times -2? And what is 7x minus 2x? Jackpot. So now that we have factored the quadratic side of the equation, we want to acknowledge the fact that each of the factors has to, in its own right, potentially equal 0. There's this idea in math, and it's really like a 2nd or a 3rd grade idea applied at a high school level. And it says, if I multiply the red thing times the blue thing, and the answer is 0, then logically we can identify or come to the conclusion that either the red thing or the blue thing has to equal 0. It's called the zero product property. It's a no-brainer. What number would make the underlined red part equal 0? So one of my answers to this quadratic equation is -7. What number would make the underlined blue part equal 0? So my other solution is 2. Notice how I wrote that. I did not use parentheses. You should just copy it directly off the TV. X equals -7, comma, X equals +2. And that, as they say, is that. Okay, what makes this work is the fact that it's equal to 0. That's what that last step is all about, is if two things multiply to make 0, then one of them has to equal 0. And since we don't want to play favorites, we just set them both equal to 0. Here's your next one. M squared minus 10m equals -16. So what's wrong with this problem? It doesn't equal 0. So we're going to fix that by doing what? Add the 16 to both sides. We're going to get m squared minus 10m. Good. No matter when I had you, if it was last year or 2 years ago, you learned how to factor quadratic trinomials. And so hopefully this is feeling like, yeah, I remember this. So I know now to factor it, I'm going to start with my 2 blank shells. And I know that I can put an m at the intro to each one, because m times m makes m squared. What is my next objective? I need the 16, right? Remember, if you're focused on the -10, you're just not listening. You're trying to go rogue on me. Your focus is to multiply to make a +16. And there's a lot of ways to do that, and I mean a lot. But this is where then I start to think about my secondary objective, and I say, okay, while I'm thinking about multiplying to make +16, I know at some point the 2 in the middle and the 2 on the outside are going to have to add to make -10. So then it doesn't take a math degree then to figure out, well, they both have to be minus or negatives, because that's the only way to multiply to make a +16, but then eventually add to make a -10, right? So at this point, you know, you got 1 and 16, 4 and 4, or 2 and 8. I think you've got it already. What's the obvious choice? 8 and 2. 2 and 8, 8 and 2. Order does not matter with these simple ones. Put anyone anywhere, it's going to work. And if you're not sure of why that works, again, just check it out. There's a -8m. There's a -2m for a grand total of jackpot, -10m. So what's my first solution that I get from here? M equals +8. And how about here? Presto, done. Okay, I got one more easy one, and then we're going to bump up. If you remember, these start to get harder when you put a number in front of x squared. So last of the simple warm-ups. What do we do? Yeah. Don't subtract x squared, because that's going to turn him negative. And I don't know that you should remember everything I say, but you shouldn't. But this guy is important because it's like he's like the granddaddy term of the problem. And he says, if I'm positive, you leave me alone. Don't move me. You make me negative, and factoring gets a lot harder. So leave me, bring everyone to my side. And so I'm going to leave the x squared where he is. And I'm going to bring plus 4x and minus 45. So our primary objective is to multiply to make -45. We know for a fact that we can go ahead and put an x in the beginning of each shell. What are we thinking when we multiply to make a -45? Right, you got to have one of each. One positive, one negative. And now you just start running through all the numbers in your mind that multiply to make 45. And there's 1 and 45, 3 and 15, or 5 and 9. None of those directly are going to add up to make 4, but based on the fact that one of them has to be negative and one has to be positive, who are they? 9 and 5 of some flavor, and I want the 9 to be the positive one and the 5 to be the negative one, right? And that works. It verifiably works because when you multiply these, you get positive 9x's. When you multiply these, you get negative 5x's. And well, 9x minus 5x, jackpot. So what are my solutions to my equation? Good job. So that's your nice little friendly warm-up, right? So those are quadratic trinomials, simple. They shouldn't take too long. And then we, of course, bump the difficulty up now by putting a number in front of x squared. So let's look at this. So I went ahead and just made this one equal 0 since it's our first sort of journey into the harder ones. So we don't have to worry about moving anything to one side. We're set. We got it equal to 0. This time, when I build my multiplication shells, I cannot just brainlessly, robotically put x's there. You're not supposed to say this kind of stuff, but that's pretty stupid if I do that because x times x doesn't equal 3x squared. So you'll remember that we sometimes have to modify. So like in this case, we have to put a 3x in one of them and a single x in the other. So my objective right now, first and foremost, is to multiply to make a negative 6. So I'm going to go off to the side here, and I'm going to make a list of every possible combination. I'll write them in red. Every possible combination of numbers that multiply to make negative 6. 1, negative 6, negative 1, 6, 6, negative 1, negative 6, 1, 3, negative 2, negative 3, 2, 2, negative 3, negative 2, 3. Now, you might, like Gavin asked a question earlier, and you should always ask your questions. You might ask something like, well, isn't like this one the same as this one? Are they the same? They're not. And the reason now that they become not the same is because of that stupid pesky 3 that's in front of the x. So now the location of your numbers really matters. So like if I put my 6 over here, I'm going to write this in yellow. You don't do this if you don't want to right now. But if I put the 6 over here and the 1 here, you see I have power played the 6 on the 3 to make 18. Right? Whereas if I put the 6 over here and the 1 over here, I've effectively neutered the 6. By not pairing it with the 3, now it's only a 6, right? So please understand that when I wrote down 8 things on the right, each of them is uniquely necessary to consider. So if you have sat through my spiel before, you know how I feel about this. This is where we just roll up our sleeves and we try and we err. It doesn't make you stupid. It makes you a good math student. If you try, fail, try, fail. And on the 7th time, maybe you go, oh, I got it. Ah. Sometimes you get it on the first try. So what numbers should we try? They just have to multiply to make negative 6. That's all I care about right now. You can pick. I'll drink coffee while you decide. And I'll wait too, by the way. I'm very patient. I've got nowhere to go. Thank you. Thank you for taking some initiative there. So we're going to test drive a negative 2 and a positive 3. Now, if this works, nice. If it doesn't, don't forget, that doesn't mean negative 2 and 3 are failures. It means we might have to try them in another order. Same numbers, different places. So let's see how Alyssa did. What do these make? What do these make? And what's negative 2x plus 9x? Jackpot. First try, success. Okay. Is this all looking really familiar to you? Good. So let's consider the first set of parentheses right here. What solution do we get out of that? X equals 2/3. Good job. And what solution do we get out of the second batch? Negative 3? You're fine. Just put a comma between them, put a box around it, and you're on to the next one. A really ambitious student might take the time to check those answers. You're always welcome to plug them back in and check them. It's not going to be part of this lesson, but you're welcome to do that. Okay. This is my last example for this because this is review. However, if you want more as you're working on your assignment today, I can certainly come around and help you out. Or you can come up here. But anyways, let's get to it. So what's step one? Move the 19x. We want all our stuff on one side, and we want the side to be the left, not because we love the left side, but because Mr. 6x squared says, I am positive, leave me be. So I don't think you're going to find many instances where that's the guy that you have to move. It'll happen, but not right away. So let's leave 6x squared alone, and let's tuck the 19x as a minus 19x right into the center. And then we'll bump the minus 20 off to the side. Any questions so far? You want your polynomials to be in order. You have to have them in standard form, x squared, then x, then number, then 0. So let's get to it. Why is this one harder than the last one? Because there's multiple ways you can make 6. So this time I can't just jump in and just pick one and assume it's going to work. I have a lot of options here. If you remember these, you remember these ones kind of suck. They're harder. And so I have potential that my answer might look like this. I also have potential that my answer might look like this. We agree that those both make 6x squared. The question is, which one is it? And the answer is, we don't know. And so that's where we just grab a pencil and paper and we just try things until they work. So again, I'll wait for your input. Would you like to choose the top template or the bottom template? And which combination? I'm not going to write every combination of negative 20 out. You know that there's a lot. So which template, which pair? Top 4 and 5. I like it. Let's just take some initiative and let's just say, what the heck? Let's put in a +4 and a -5. Because whatever comes of this, I know and you know that those make negative 20. So we have checked that off our list of things to worry about. What's distracting over there? Can you tell me what it is so that we can talk about it and then be done? What's distracting over there with all the heads looking out there? Is there something? Okay, can you ignore them? Just ignore them, maybe? Thanks. I always say this job's hard enough when you are paying attention. It's infinitely harder when you're not. Thanks, Jared. Man. So when we talk about testing this is, if you suck at factoring, this is usually where you suck, is that you don't take the initiative to just try. Does it work? You know, you don't walk up and say, can you tell me if I did this right? The answer is check it yourself. What's 4 times 2x? What's 3x times -5? And what's 8x minus 15x? It sure as heck isn't -19. And we don't get all, oh, I'm dumb. No, it doesn't work. Boo-hoo. So you move on and you try something else. What else you want to try? 6x, 5x. Okay, so Bryn has hopped us down to template number 2, and you want minus what? 5 and +4? Okay, let's try this. Maybe it'll work. This is the process. If you've forgotten, now you're reminded. The process of factoring is trial, error, trial, error. It happens. So let's see how Bryn did. So we know that the bases have been covered. What we don't control is what's this times this. What's this times this? What's -5x plus 24x? 19x. Positive 19x. And so now I'm going to go back and look at what I was trying to accomplish, and I'm going to say, good try. Do not switch the 4 and the 5. That is a great thing to say, and don't get upset because it's wrong. This is how we learn. You do not move the physical objects. You merely change their signs. Once you get the right number with the wrong sign, leave everyone where they are, change the signs, and you're done. So we're going to change this to a +5 and a -4. And you see how that changes the whole dynamic and balance. Now, when you multiply the 2 in the middle, you get positive 5x. And the 2 on the outside make the -24x, and 5 minus 24, jackpot. And then, of course, now that all the hard work is done, you simply solve the equation. So yet again, what answer do you get from these parentheses? -5/6. And this one is +4. And that's that. We could do this all day, but I feel like in fairness to you, should probably cut this off here and let you start doing some problems. Hopefully you don't encounter too much stress. I think I put it in Delta Math. No, it's not in Delta Math. It's a PDF. I forgot. I need to post it up to Canvas for you real quick. So I'm going to end the recording. Give me about 1 minute and then it'll pop up. I'll let you know when it's up on Canvas for you.